Hi everyone, this is Poornima Mahalingam. Today in this video lecture series, we are going to discuss a topic about three-phase induction motor. In previous classes, we have discussed about working of single-phase induction motor and why it is not a self-starting motor. In this video lecture series, today we are going to see a review of three-phase induction motor. Come, let's go to video. Here the three-phase induction motor. What was a three-phase current? How the three-phase current? The phase A, phase B, and phase C. So phase A current IA with cos angle 0 degree. Phase A with an angle 0 degree, and phase B with an angle of minus 120 degree, and phase C with an angle of plus 120 degree. So we have three-phase current IA, IB, and IC with an angle of 120 degree, leading and lagging. This is a three-phase. So minimum current and a current maximum and direction with an angle of 120 degree. Here the rotating magnetic field. How it is the rotating magnetic field? We have one as a R, Y, and BB, RYB. Here we can say assume the current waveform as the top figure, and the t is equal time is equal to 0. That phase red phase in a positive maximum, and yellow and blue can both in the at a negative half. So red in positive, and both yellow and blue is in a negative half. And each of these current produces a magnetic field. This field is inside the form net of first sequence in the figure. The magnetic field resembles that associate with the two poles bar magnet and associate with the minimum of two pole motors. Okay. Here the rotating magnetic field. Here now the next thing. Now what happens? The red current falls. The next thing is the red current falls. Then yellow and the yellow current becomes less negative and becoming the yellow current become less negative. Eventually become positive. Blue current approach negative. So blue current approach negative and the negative minimum. So hence the second sequence shows the portion of 1/3 cycle, that is 120 degree electrical, and the yellow current is at the positive and the red and blue current both are the negative. Yellow current goes to the positive and red and blue will be the negative. Okay, this is the next 120 degree cycles. Next 120 degree cycles, what happens? Here the blue comes positive and yellow and red comes negative. Okay, this is what the rotating magnetic field. Here the rotor slip. And then consider a simple rotor, one short circuit coil. Here the what about the slip? Initially the rotor is stationary. The moment the stator supply switched, no current started to flow from rotating magnetic field established. The relative motions between the moving field and the stationary rotor conductor induced EMF in a stator rotating conductor with the help of Faraday's law. Here we can see some video about three-phase induction motor. Come, let's see the video and then we can discuss. It's a common used electrical machine. It is in this motor. So here we used a squirrel gauge type rotor. We have stator. It is a stationary part. Rotor is a rotating part. And the rotor here we used is squirrel gauge rotor. So it is steel laminated. It is steel laminated. Here we can see the winding passes through. Here's the winding passes through. Here the magnetic flux is produced. There's a magnetic field is produced. Here we can see three-phase winding, magnetic field. So single coil produces a magnetic field. This is single phase. What about three-phase? So we have already seen this. So now we can see the working animation. Here the different orientations. This we have already discussed. Here we can see the magnetic field. What happens when blue is in positive peak? What happens? Synchronous speed. The speed is constant, so it is known as synchronous speed. closed context. So EMF induced. Yeah, the extra conductor is placed. Yeah, the loop was not rotating. Correct. Excuse me. Yeah, the stator, same it is in rotor. So magnetic field produced. Yeah, the magnetic field induction motor. So insulated iron core is laminated inside the core. So because of this, eddy current losses is minimum. This is mostly used in three-phase induction mode. This is in self-starting motor. Magnetic field in rotor is rotating. Rotor speed is magnetic field is with same speed. Here we have a constant magnetic field. EMF is induced. F is force is equal to 0. Here the rotor slow down. Now the rotor speed is less than synchronous speed. That is slip. The difference is slip. NS minus slip. Here the stator input is output from motor. Here the stator. So we have fan for cooling. Here the input is we are giving in rotor and output we are taking from stator. Okay. Yes, today in this video we have discussed about working of a three-phase induction motor and working principle of three-phase induction motor. What happens? How the phases are working. Okay. With the next other topic we can see in next video series. Thank you.